All right, so here we go. We've got how much current does a 24 volt, 1/4 horsepower motor that is 90% efficient draw from the bus? Okay, so what we're looking for, this is a very difficult problem for not having covered electricity yet, but at the end of the day, we're looking for current. So we have to find current. So that this is actually a two-step problem. These are two individual problems put together. Whenever you do the electricity section, step one will be its own problem, step two will be its own problem, and then they'll have a problem like this as well. Okay, so let's start with step one, the efficiency. So what is motor's efficiency? So a motor, whenever I have a motor and I go buy a motor and it tells me that it's a 1/4 horsepower motor, what that's telling me is that the shaft of the motor turns with 1/4 horsepower. And if it tells me it's 90% efficient, that doesn't mean that the shaft of the horse or the shaft of the motor is going to turn less than 1/4 horsepower. It's telling me that it's 90% efficient, meaning it needs to take more power in. So this is, in our case, an electric motor. So it needs to have more power come in than it's going to come out. That's going to be put out by the shaft. That's what efficiency is. Efficiency is equal to output power over input power. So you probably know, but you will never have a motor be 100% efficient or over 100% efficient. If you did that, you'd be breaking the laws of thermodynamics, and you'd also just be the richest person in the world because you'd have come up with an invention that has more power coming out than putting in, than that's coming in. But regardless of that, so what is saying 90% efficient? It's meaning that it's going to be drawing more power from this battery or from this source than the shaft is going to be turning with. Okay, so that being said, we have to know that equation for this problem. So efficiency is equal to output power over input power. So what is our output power? The output power is the shaft power that is 1/4 horsepower. What we're talking about here, though, is this is going to be power and electrical power. So we'll go and pop over to the bottom. What is power? Power is, in electricity, is the watt. So we're going to have the watts. We need to know the watts that this motor draws to run the shaft. So what we're essentially doing is just going to convert horsepower to watts. So it gives us that equation or that conversion right there. So we know 1 horsepower equals 746 watts. So 1/4 horsepower is going to be 746 times 1/4. So that comes out to be, so the output power is 1/4 horsepower, or if I convert it to electrical power, 186.5 watts. Does that shaft actually turn with electrical power? No, it's mechanical power. That's horsepower is mechanical power. Watts is electrical power. But we're converting it so that we can use this equation to find the input power. So we do know our efficiency is 90%, so we need to convert that to a decimal. So just move the decimal over 2 places to the left. So it's going to come out to be 0.9 equals our output power, 186.5, divided by, instead of writing input power every time, I'm just going to put I. So we're looking for input power. So we're going to use algebra to solve this equation. So we're going to multiply both sides by I. I divided by I is just 1. Anything divided by itself is 1. So we're left with 9I. Just change the order. It doesn't matter. Equals 186.5. And finally, I'm going to divide by 9, and I'm left with I, or my input power, is equal to, 207.22 watts. So we've solved the first part of this problem. Again, this is a difficult problem for not having covered electricity. So that's the efficiency side of it. So we found that it takes 207 watts to run a motor that's output is 186.5 watts. And that makes sense because that's how efficiency works. If your input is ever smaller than your output, you know you've done something wrong. Okay, so now that we have this information, I is actually their input power. So I'm going to go ahead and change that to be power because that's what it is. So this is power and electrical power. So we're going to bring that down to our step 2, 207.22 watts. Okay, so now we're going back to the problem. What does the problem want? It wants current. So these are the two main equations for electricity. You're going to definitely need to know them for the electricity section. So we have ear and we have pi. So let's look at ear. So ear is the equation. It says E equals I times R. Some people like to use this triangle. We'll talk about it in a second. What is E? E is voltage. I is voltage in volts is the unit of voltage. Current, the unit of current is amps. And then we have resistance, and the unit of resistance is the ohm. And our second equation is pi, and this is the one with power. So we have electrical power is watts. Current is amps, and voltage is volts. So to solve any one equation, we can only have one unknown. So we have to pick between these two equations. Are we going to use ear or are we going to use pi? So again, what is it that we're looking for? So we are looking for current. So let's look at here. We have current and current. Okay, what else is given to us? What else is given to us is our voltage. So our voltage, E, is equal to 24 volts. So we do have our voltage. So we have this voltage here, and we have the voltage here. So we have our current. So we're looking for current. But what else do we have? Do we have the resistance? We don't. Do we have the power? Yes. So what equation can we use? We can use pi. So we're going to go ahead and use pi to solve for the current. So P equals IE. So our power is 207.22 watts. Our current is what we're looking for. We do not know that. And our voltage is 24 volts. So we're going to use algebra once more to solve for this. Divide both sides by 24. Divide both sides by 24. And that comes out to be 8 point current is equal to 8.63 amps. Just a quick note. So if I was going to, instead of doing algebra, you can use these triangles, but you do have to memorize the triangle. So in our case with pi, what we wanted to have to solve for was I. So I'm going to put my finger over I like this, and then it will just be P power divided by voltage, or P divided by E. So I could do that for any one of these. The other example would be if it was current I was looking for, and I had if it was voltage I was looking for, so I'd cover up the E in the triangle, and if I had current times resistance, then I would multiply current times resistance. So if it's on the bottom layer, you're going to multiply like this. If it's the top over the bottom, you're going to divide like that.